In this segment, I'd like to talk about some of the basic tools that you're going to need to either put together a PC from scratch or perhaps upgrade an existing one. Now, there's not only tools to assemble the machine, but there are some protective tools that we should talk about. And what I mean here is ESD protection. And ESD stands for electrostatic discharge. Now, I don't want to sound like your mother here, but when you spend $800, $900 for some of the high-end processors, you want to make sure you're going to have a little bit of protection so that you don't zap one of those chips. Also, when dealing with motherboards, processors, circuit boards, things like that, you want to be a little bit careful. Now, when most people think of ESD protection, the first thing that comes to mind is a wrist strap. And what that does is it basically is a strap, and this is an example of one. I happen to like this style. This is a sort of a Speidel stainless steel band that's expandable. There are much less expensive ones available, and you basically put this on your wrist, and it has metal that contacts your skin. And then after putting the strap on, you connect a wire to the strap. And then if you're working on a chassis, you can either connect this with an alligator clip directly to the unpainted metal surface on the chassis, or in this case, what I'm going to do is connect it to this anti-static mat that I have here, and that's going to plug in right here. Now, myself and anything that I put on this mat are at the same electrical potential, and right now I have a motherboard sitting on the mat. So that means that if I touch any components on this motherboard, there's going to be no flow of electricity. Now, one thing that always comes up when we talk about ESD protection is people say, well, this whole thing should be earth grounded. I should be, like if the system I'm working on, for example, should be plugged in because the third wire leads to ground. And that's not true at all. I mean, it does lead to ground, but being earth grounded is not important. In fact, you should never work on a machine that's plugged in because modern systems have standby currents and voltages, meaning that the system is always partially on. And if the system turns all the way on and you plug in a component, you can actually do damage to both the component and the motherboard or possibly other circuitry in the system. So never work on a PC that is plugged in. The purpose of this whole ESD protection system is to keep yourself and any of the equipment you're working on at the same electrical potential. If you have a potential from ground, that's okay. All that matters is when I touch something that there's no flow of electricity. And right now, with myself connected to this mat, myself and the motherboard sitting on this mat are at the same electrical potential. Now, assuming I'm going to later take this motherboard and put it in this chassis, I should also make sure that anything in this chassis is at the same potential as well. And for that, I have another wire which is connected to the mat and has an alligator clip on it, and I'm going to connect that clip to an unpainted metal surface on the chassis. It can really be anywhere on the chassis of the machine as long as it's not a painted part or a plastic part. And now, myself, anything on this mat, and anything in this chassis are at the same electrical potential. Now, normally if you're working on a PC as in removing components, you set this all up with the mat, the wrist strap, and such that when you take parts out, you then set them on the mat. So again, they stay all at the same electrical potential. Now, a lot of people, they don't have the wrist strap and the anti-static mat, or even if they have them, they tend not to use them. Does that mean if you don't use this stuff, you're going to destroy everything you touch? Well, probably not. I mean, in a lot of cases, it depends on the environment you're in. Is it humid, or is it dry? If it's dry and it's 0 degrees out, it's in the depth of winter, and everything you touch, you're getting sparks, you might want to consider using this. If it's in the summer or you live in a more humid area, it may not be as much of a concern. I'll tell you, there are a couple of precautions you can take, though, if you don't have this equipment. Now, wrist straps and mats and such are not very expensive, but assuming, let's say you don't have this equipment, what you can do is this. Before I would go to pick up a motherboard without using this type of protection, I would touch one of the surrounding shields of the connectors on the back panel here. If you can see here, I've got various connectors on the back, and they have these metal shields. If I touch that first, before I touch any other part of the board, if there is a spark, if it's to that metal shield, I'll be much less likely to do any damage. You should not touch any of the circuits on the board without first touching one of these ground points. That's a grounded point on the board. And likewise, if you're picking up a circuit board, if you pick it up by the bracket part of the card, that's also a ground part in the card. And if you were to spark to that, it would be less likely to do any damage. So ESD protection, is important. Some people don't, take it so seriously. I'll tell you this though: if I'm working as a professional in somebody's office and I'm hired to work on their machines, you better believe I'm going to get out the mat and the wrist strap. I think it looks very unprofessional if you just start taking parts out of their computers, laying them all over the various tables and things. It doesn't look professional. It may cause damage or problems, and you don't want it to be blamed for any problems later. And the difficult thing about ESD damage is that it's hidden. You don't know whether you've damaged a chip. You put the board in and then suddenly it starts acting flaky or not working properly. Was it you? Was it that spark that you saw? And a lot of times these aren't even sparks you see. You can have a potential and cause damage without even a visible spark. So anyway, enough about that. Let's look at some of the other tools you're going to use to put together a PC. Of course, everybody falls to the basic screwdrivers, and I have your standard flat blade and Phillips screwdriver. The Phillips screwdriver is useful. A lot of the screws used to hold the back onto a case, for example, or to screw a motherboard in are Phillips screws. I'll tell you what though, you should never be using flat bladed screwdrivers and flat head screws. Slotted screws, I mean, when assembling a PC, because there's simply no positive retention for this. The worst case would be on a motherboard. If this tool slips out of the screw head and gouges the motherboard, you're going to cause damage if you cut one of the circuit traces. Now, almost every motherboard manufacturer I've ever talked to says that if you send a motherboard in for a warranty repair, the first thing they're going to do is check around every screw hole and look for gouges. And if they see gouges next to the screw holes, that's going to void the warranty on the board. Bottom line, a flat-bladed screwdriver like this should be nowhere near working on any PC. In fact, a lot of the screws that are used to hold motherboards in particular are the Torx head screw, which is a star-shaped screw, and it requires a Torx bit like some of these that I have here. Now this is a nice set of tools. This is a standard set of various bits and nut drivers in different metric and English sizes. And over here you can see all the Torx bits. These are the star-shaped ones. And what's great about these is they're even better than Phillips for positive retention of the tool. That is, the tool goes into the recess on the screw and it doesn't tend to jump out or walk out. So that's why you'll see the Torx screws used in a lot of PCs. That's actually a good thing. I know some people have complained, because they don't have the Torx drivers laying around, but it is something that you really should have if you're working on PCs. Now, one of my favorite things to use, instead of a regular screwdriver, I like to use a power screwdriver when working on PCs. This is an example of an electric screwdriver, and this type uses interchangeable or replaceable batteries. That is, I can have several batteries and keep a few extra ones charged, so when the battery I'm using dies, I can really pop in a new one and then continue working. So using an electric screwdriver is great. This one also has a torque adjustment so that I can set how tight I want the screws to be. So when I tighten the screw, it reaches the appropriate tightness and then starts slipping. It makes a sort of a ratcheting sound, and then I know that the screw is at the appropriate tightness. So this is kind of a nice one. Again, be careful when using an electric screwdriver to put in the motherboard. That's one case where I might revert back to the hand tool, simply because if that were to jump out of that screw, you'll leave little circular gouges next to the screw hole, and I've seen that several times. And it's not a pretty sight, and you'll be buying yourself a new motherboard. Now this is an example of a different type of electric screwdriver. This one has a pivoting capability, so I can turn it like this. Sometimes it's good for getting into tighter spots with this type. And again, this uses the replaceable battery, so I can keep some extra ones charged, ready to go. I mentioned nut drivers before. These are some of the typical sizes of nut drivers that are used on the screws, the hex screws that hold PCs together. Or you can use the comprehensive bit set like I showed you before. This one has all the various sizes, so no matter what size you might encounter in a particular PC, if it's a hex screw, you can use one of these nut drivers. These are great, again, for not slipping off of the screw and causing damage. Now another accessory I wanted to show you for the screwdriver is this. A lot of times, it can be difficult to get around inside of a case. This is a flexible attachment for an electric screwdriver, and what allows you to basically bend it around corners. So I can tighten screws even though this thing is curved. And basically a flexible rod is inside this channel, and it allows the tightening sort of at an angle. It works really good. So these are available at most hardware stores. Now, one thing that tends to happen is, you get most of the PC together and then you drop a screw down either on the motherboard or somewhere in the case, and you hear it rattling around. Not a good idea to leave loose parts rattling around inside the PC. So for that sort of thing, I like to use this. This is a claw parts grabber, and this thing is great for reaching into a case and picking up a screw or maybe a loose jumper or other part that's fallen in there. These things are also sold at automotive tool stores, and they do work great when working on an automobile as well, if you drop a bolt or something and you need to reach in and pick it up. I once dropped a screw down the defroster vent inside of a dashboard, and it was rattling around, and one of these was able to snake down in there and pick it out without having to take the half the dashboard apart. So great for PCs and cars. Finally, I come to these hemostats. These are great also for picking up small objects. This is a longer pair here, and then I have a smaller pair here. And not only for picking up objects that you drop, but these are great for putting jumpers on, especially in a tight place, to put the jumper on the set of pins without messing it up. These things are great. They get a positive grip on the jumper, and you can precisely place it. So I love having a couple sets of hemostats around. These are also available at tool stores. Radio Shack sells these. A lot of places you can buy these. Now, working inside of a PC case, oftentimes you don't have the kind of light that we have here, so almost invariably I end up using a flashlight. And if you're in the computer business, a high-tech industry, why not use a high-tech flashlight like this one, for example? This is an LED flashlight. And with the advantage of using LEDs is, of course, that the battery, they use very little power, they produce very little heat, and the batteries last incredibly long. So I'll always have a flashlight in my toolkit, one in my briefcase, and I end up using them all the time to peer inside of a PC into the dark recesses and see everything that's going on. So a flashlight is invaluable. Finally, I have this. This is basically a basic multimeter, and this is great for just verifying that you have current at the wall socket, for example. You can set it to the AC volt range or set it to DC volt ranges, and you can verify that the power supply is putting power out, things like that. You don't really need this to build a PC unless you run into trouble. But if you do have any trouble, you can sometimes use a tool like this to help figure out what's going on. Well, these are just some of the, the most basic tools. As you can see, not really a lot required. PCs are very simple to assemble. In fact, a lot of the newer chassis are more of a tool-less design. You can now install drives and all kinds of things without even picking up a tool. And that, of course, makes the assembly even easier.